Hello everybody, welcome all of you again in our LeetCode series. Today we are going to solve problem number 202, which is happy number. In this problem, we have given that write an algorithm to determine if a number n is happy. So now we can see that what a happy number is. So here is given that a happy number is a number defined by the following process. So starting with any positive integer, replace the number by giving the sum of the square of its digit and repeat the process until the number equals 1, where it will stay, or it will loop endlessly in a cycle which does not include 1. Then those number for which this process ends in 1 are happy. So if return true if n is a happy number and false if not. So now we will check our intuition how we will going to solve this problem happy number. So replace the number with the sum of a square of its digit, repeat the process, and if we reach 1 after sum of a square of its digit, then it will be happy number. If we get into a cycle that does not include 1, then it will not a happy number. So what approach we will going to take for solving this problem? So we will first calculate the sum of a square of its digit. We will separate a number according to their digit, uh, then replace the number with their sum uh, of a square of its digit, and then repeat until number becomes 1. We will repeat this process until we will get 1. Then if we will get 1, then we will return true. If number repeats, then we will confirm that cycle detected and we will return false. So this we will need a helper function for sum of a square of its digit. Then we will see in code base. So here is no use. We will discuss this in code while writing code. Then take a first example. So let's say we have a example as 19. So you can see this is 2-digit number. Then we will separate this with each digit wise. Then we will get 1 and 9. Then we will square of each individual digit and then add that. Then if we will square 1, then we will get 1, and we will square the 9, then we will get 81. Then 81 plus 1 we will get 82. You can see here, and then again repeat the cycle. Now we will again separate this with digit 82, then we will get 8 and 2, then we will again square individually and then add. Then a square of 8 is 64 and a square of 2 is 4, then 64 plus 4 is equal to 68. Again we will repeat this process until we will get 1, or repeat the cycle. Repeat the cycle means again we will get 19 as well. And then you can see at after 4 steps we will get 1. Then now we have this as a happy number, then we will return true. And now we will go to example 2, which is 2. So if we will square 2, then a square of 2 will becomes 4. And then again we will, if we repeat this process, then we will get 4, a square of 4 is 16. Again 1 square plus 6 square is 36, and 1 square is 1. Then 36 plus 1 becomes 37. Again we will repeat this process, then it will becomes this. Again if we will repeat this process, we will get 89. Again we will repeat this process, then we will get 145. Then if we repeat this, we will get 42. Again if we will repeat this process, we will get 2. and again if we will repeat this process we will get 4. Then you can see that here this is 4, and again we have a 4, here is 4. Then we can think that it will repeating a cycle. Then we have confirmed that we are repeating a cycle. That means 4, 16, 37, 58, 89, 145, 42, 20, and again 4. We have reached again 4. Then we are in a loop and we never reach 1. So this is not a happy number. So how to detect cycle? Then for detecting this cycle, we will use two pointer methods. One will be slow and one will be fast get some. This will be helper function. And now uh, we will see in code base. So why it works? If there is a cycle, fast pointer 2 steps will meet slow pointer 1 inside the cycle. Then its complexity would be now we should move to code base. So now we will move to code base. So we will write first helper function to uh, uh, to get the we need helper function that calculates the sum of a square of its digit. So now we are going to code. So we will write int get next number next with a argument integer n. Then we will initialize sum because we need sum of a square of its digit. Then again we will write a condition while num will be greater than 0. While num will be greater than 0 we will repeat this process. Then we will separate the digit. We will get our last digit using n modulus 10. This will give a separate last digit. Then we will sum a square of its digit. Then we will digit into digit. Now we will remove the last digit, and we will continue this until n becomes 0. Now we will return finally we will return sum in this helper function. Now we will come to main function. Inside this we will use hash set because for loop you can think that we have a problem which will finally get result as one, either one, and we will found a cycle or a loop. Then if one will come then we will return true obviously. Then and if we will not get one and we will repeat a loop, we will repeat the same number as previously seen. Then for that we will use hash set because you can you should know that hash set always stores unique number. So if numbers will repeat then it will check from hash set and it will return automatically false because loop will be repeat. So for that we will use unordered set. Ordered set with integer, and we will name variable as sin. Now we will write a condition while n is not equal to 1. Okay. Now we will write a condition if not sin dot count. Sin dot count if not sin dot count, then we will return false. Okay. And if we will get a new number then we will store in a hash set. So for this we will use insert method. So sin dot insert in, and we will update the n with next chain, sorry, get next, get next of n, and we will finally return false, sorry, true. Now we will go for a test case result. Yes, we have passed the two test case. So now we are gonna submit this solution. So yes, you can see that our solution has been accepted, and now we will discuss for time complexity and space complexity for this solution. Then time complexity would be O, big O of log n, because number of digits decreases or remains bounded by a constant after each transformation. Hence, total steps are big O of log n, and space complexity would be big O of 1. We are using only a few variables. So what we are taking important notes from this problem. So the maximum number of square of digit for any 32-bit integer is 243 for this. So all numbers eventually enter a cycle within a number 1 comma 243. Okay, so we will take care of edge case. If n is equal to 1, then we will return true. If n is less than 1, is not a valid, given n is a positive integer. So now we will, so thank you everybody for being here. We will meet in